biology, everything. So I'll be going to the NCERT maps, and the weather is so good. It's like raining and it's chill. It's like good to study, that coziness. Well then, let's get started. Why to waste time? State of cases. Breathing and respiration. Atmospheric oxygen exchanges CO2 products. First thing foremost, breathing and exhaling as well. Breathing and respiration is the point here. Breathing and the respiration. Atmospheric oxygen is exchanged and CO2 is produced by the cells, and that is everything with the exhalation or the inhalation that CO2 is produced. From that point, exchange takes place and CO2 is given out and oxygen is absorbed. Then we have the human as respiratory organs. This we have based on habitats and levels of organization. Respiratory organs are divided on the basis of habitat and the different level of organization. Certain organisms and its mechanisms. Sponges, cylindrical flatworms have simple diffusion. Earthworm, its moist skin. Then insects, its tracheodes. Aquatic arthropods and mollusks and fishes, branchial gills, branchial/gills. Amphibians, reptiles, eels, mammals. Pulmonary lungs. Amphibians show cutaneous respiration all the time. So this is something I'm not working on. Most of the time, amphibians will be showing cutaneous respiration. Then we have outlook of human respiratory system. Outlook of the human respiratory system. First thing is nostrils. From nostrils, it's all the air which enters the miliary the nasal chamber. With the nasal chamber travels to the pharynx. And in the pharynx, before that, we have something known as epiglottis. Elastic cartilage bone that covers blood distributing swallowing. That's epiglottis. After that, we have larynx. Then we have trachea. Then bronchus. In bronchus, one can split primary, secondary, tertiary. And then these are inside. So from bronchus, it's inside lungs, like the primary, secondary, tertiary bronchi. And then we have bronchiole, like the pneumocule, alveolar. Here, in close contact with thoracic lining, outer, inner is in contact with lung surface. Inner membrane is in contact with the lung surface. Outer lining is in contact with the thoracic lining. With respect to pleural membranes. Pleural membranes important. Then we have pleural fluid also, which reduces friction on the lung surface. Pleural fluid reduces friction on lung surface and pleural membrane covering outer covering and inner covering, like muscle. So common passage for food and air is pharynx. Larynx is voice box. Trachea divides at fifth thoracic vertebra. At fifth thoracic vertebra, trachea divides. Then till here supported by incomplete cartilaginous till tertiary. Okay, from initial bronchial it's not till tertiary. Supported till incomplete cartilaginous. And then after that it's not supported. Internal bronchial parts. Vascular bags with the thin irregular walls. That's alveoli. So how much is the conducting zone and how much is the respiratory zone? So tertiary goes up to conducting zone. The one with respiratory zone actually starts. So if we go for the conducting zone's functions, conducting zone, main is humidification of air, transport of air. And this is something main. Humidification of air, transport of air, traps dust stones are exchanged gases. Now this is given as this part. So this is known as only exchange of gases. Now let's go to mechanisms of breathing. We came across breathing and respiration. We took an outlook on human respiratory system. We got used to the respiratory organs and how, based on organ system, how they're classified. Then now we are going to go through the mechanisms of breathing. After mechanism, we have exchange of gas. Okay, let's speed up. Here, mechanism of breathing. Lungs enclosed in an anatomically airtight thoracic chamber, essential for breathing as we cannot alter pulmonary volumes directly. We cannot alter pulmonary volumes directly. That's one of the key points. Lungs are enclosed in an anatomically airtight thoracic chamber. This is an airtight thoracic chamber. Okay. The movement of air follows the pressure gradient. The movement of air follows the pressure gradient. Okay, so specialized set of structures are involved in breathing, like the vertebrae, dorsal, intercostal muscles, lateral, sternum-ventral, ribcage, then diaphragm, posterior. Changes of intercostal muscles, changes volume in dorsoventral axis. In contraction, the intercostal muscles changes volume in dorsoventral axis. And contraction of diaphragm changes volume from anterior posterior. This is anterior for diaphragm. For intercostal muscles, it's dorsoventral. Additional muscles involved in expiration is abdominal. Abdominal muscles are also involved in expiration. Normal rate of breathing is 12 to 16 times per minute in adulthood. 12 to 16 times per minute is said as the healthy breath count. Now, this involves certain rules. That is inspiration and expiration. Intrapulmonary pressure is low, then expiration is high. The pressure in the lungs with respect to the atmosphere. So then inspiration, negative inspiration, positive expiration. In the lungs, if the pressure is less, then anything moves with the lungs inspiration itself. And if the pressure is more, then it's expression. So the gas should be thrown out from the lungs. In the shape of diaphragm, it's flat and then the inspiration. Door shape during inspiration. Okay. Then we have exchange of gases. Exchange of gases. Partial pressure drives respiration. Partial pressure, like what there is a pressure gradient, as the flow of gas follows pressure gradient. And here we get something as partial pressure value. Okay, it drives respiration. This value itself is like the base for respiration. Site of exchange, alveoli primary, no doubt. Then we are between blood and tissues. In alveoli, there we can exchange between blood and tissue, or the cellular level type of respiration we get. So partial pressure is the pressure contributed by an individual gas and a mixture of gas. So the pressure contributed by an individual gas and a mixture of gas is known as pressure, partial pressure. Partial pressure. Now we have certain respiration steps and what are the values. These are very important. Respiration steps, atmosphere or CFNO2, partial pressure of gases, that is mmHg. Hg stands for mercury. Hemoglobin. Hg stands for hemoglobin. breathing slash pulmonary ventilation. When we breathe, our oxygen levels rise up to 159, whereas carbon dioxide is of zero point 0.3. This is outside the atmosphere values. And during cross alveolar membrane, less than 1 ml. During alveolar membrane, limits 104 and 40. This is O2, this is CO2. 104 and 40. 104 during lungs, 40 for carbon. Then transport of gases by blood. That time it's for 95 for oxygen. The 90 for oxygen, carbon is 45. It's like going this way. The role matters. Then we have diffusion between blood and tissues, and that is of 40. And cellular respiration also 40. Both like the tissue and the diffusion is 40 40. Powerful thing also the same thing. Cellular respiration is 45 by releasing diffusion of blood between blood and tissues, and over here the oxygen gets diffused and the cells utilize, whereas the carbon dioxide again gets poured into the blood. It travels through the blood and again gets excreted. 45 itself. And we have respiratory volume and capacities. Transport of gases, regulation of respiration, then disorders. Okay, then we're done this. Disorders. Okay, first let's go to respiratory volume and capacities. The instruments spirometer is used to measure the respiratory count or breath count actually. Capacity. So let's get down the respiratory volume and capacities. So the instrument used to measure the breath count or the lung capacity is spirometer. Its significance is clinical assessment of pulmonary functions. So how our lungs function in clinical assessments. It can have such a clinical assessments using spirometer because you get the accurate figures. Yeah. Next, minute volume. Okay, tidal volume into respiratory rate, that is tidal volume is 500 into 12. 12 meaning the 12 to 16 times per minute in a human head that time. So minute volume is this 500. This is important. They ask for it sometimes when you calculation of it. And then we have pulmonary capacity. What is pulmonary capacity? Addition of various respiratory volumes. That is FRC. VR plus ERE. Okay, RV plus RV is residual volume plus of expiratory reserve volume. Expiratory reserve volume consists of both reserve volume consists of forced expiration and followed by after having a forced inhalation. How much amount of air can be exhaled out in the forced expiration? That's pulmonary capacity. Addition of various respiratory volumes. Example for FRC. Then a certain standard volumes. This is something which even we can assess for the clinical assessments. First thing first, tidal volume or air inhaled or exhaled per breath. So value in ml is 500 ml for TV, tidal volume. Inspiratory reserve volume or forceful inhalation, just like that you're forcing yourself. Otherwise you really normally also breathe and exhale. That exact period is like you're forcing yourself, like I should survive, I should breathe. Like that. So now I think that is Yeah, inspector reserve volume, it's about 2500 to 3000. 2500 to 3000. Now, TV plus IRB gives rise to IC. What is IC? Inspiratory capacity. And that together is around 2500 to 3000 plus or fine. Depends. If it's reaching for 2500, then it's 3000. If it's like 3000, then it's 3500. Expiratory reserve volume or forceful acceleration. Expiratory reserve volume or forceful acceleration. Okay. ERV equals to 1000 to 1100. ERV equals to 1000 to 1100. Now, residual volume or air left in the lungs after forceful exhalation. Residual volume is the air left in the lungs after forceful exhalation. It's around 1100 to 1200. 1100 to 1200. That together constitutes FRC. What ERV plus R? Now, VC comes to IRV plus ERV plus TV. TLC, total lung capacity, everything, all four components. Now EC, like here IC, like that EC, these two, VTV plus ERV is EC. Transport of gases, and this is oxygen dissociation curve. Lungs, oxygen, blood goes to tissue, and carbon dioxide this side, oxygen and carbon dioxide. Ooh, I feel this map is quite huge, but that's good. Oxygen, around 5 ml of O2 is delivered to the tissues by 100 ml of oxygenated blood. 100 ml of oxygenated blood, this is 5 ml of O2, whereas 4 ml of CO2 is delivered to alveoli, not tissues, by 100 ml of deoxygenated blood. Okay. This is for tissues oxygen. For alveoli, it's carbon dioxide. 3% is dissolved in plasma, 7% is dissolved in plasma for carbon, and 7%. Whereas for oxygen, it's 3% in plasma. 97% has oxyhemoglobin. 97% are oxyhemoglobin, and 20 to 25% as carbamino, HB, hemoglobin. Carbamino hemoglobin. Some not all. Binding of O2 with is primarily related to PO2, partial oxygen level. And binding of CO2 with HB is related to PCO2 as well as PCO2. Now, hemoglobin plus O2 gives rise to oxyhemoglobin, and that's the reverse reaction. Now, if I make HB plus CO2, carbamino hemoglobin, it is. What is it? Carbamino hemoglobin with carbon, oxygen, oxyhemoglobin. So now again we have another table which we must go to because it's really important. Here are the parameters: high PO2, low CO2, high temperature, high H plus concentration and location. So when it's association, oxyhemoglobin important, high PCO2, like high partial pressure oxygen, automatically will lead to downfall of others, whereas low high PO2, that is low partial oxygen value, then only that will fall and just all will remain better. So that's tissue and lungs alveoli. In lungs alveoli, it's positive, like in lungs, then in tissues it became negative. Whereas association here is right opposite. During association, the PCO2 decreases. Your Canada decreases. Whereas when you teach in the afternoon session, it increases. The dissociation difference. That is tissue, lungs and liver. Well, we do have some noteworthy points here though. Each hemoglobin molecule carries or binds 4 oxygen molecules in a reversible manner. So we have to much more. Okay. Oxygen dissociation curve obtained is sigmoid. Very important, I have asked this last time at NEET bit. 3 times it came like even in our module paper. So we can expect it for many people. Sigmoid is the curve of oxygen dissociation. Maximum 70% of CO2 is transported as bicarbonates. 70% of CO2 is transported as bicarbonates, facilitated by enzyme carbonic anhydrase. Facilitated by enzyme carbonic anhydrase, which exists more in RBC and minor quantities in plasma. So 70% of CO2 is transported as bicarbonates. Yeah, 20 to 25% RBC. Bicarbonic anhydrase. This is the thing. CO2 plus H2 carbonic anhydrase. H2CO3 carbonic anhydrase. HCO3 plus H plus. While coming home, I'll check. Now regulation of respiration. We have the regulation of respiration here. Humans have significant ability to maintain and moderate the respiratory rhythm to suit the demands of the body. So, yeah, we can alter it like it's our anything can't. We can just maintain. I can maintain what we have. So regions involved, pneumotaxic, okay, these are like what all are involved for lungs, like only the thoracic cavity only, or is any other connections present which help for its conduction and support. So what will be said as reading the regulation of respiration, how it's get regulated. Is it only by one mechanisms or what all are involved, what all systems are there, like backhand workers, who all are there? That we'll see. Now we have regions involved, that regions involved location, then okay, region involved one section, and where is the location of the region involved. Okay. Then here we notice its sensitivity. It gets triggered if it sees anything like that. First thing first, pneumotaxic center and pons. Pons medium. Pneumotaxic center, very important. It reduces the duration of inspiration. Pneumotaxic center has one crazy fact that it reduces the duration of inspiration. Okay, whereas chemosynthetic area, medulla oblongata. Chemosynthetic area is present at the medulla oblongata. Aortic receptors, aortic arc, aortic aroma, nose. Aortic receptor is aortic arc. Then carotid receptors, carotid artery. This is of heart. Carotid artery, carotid receptors of carotid artery. Now we have respiratory adjustments. Chemosynthetic area, aortic and carotid, carotid. We have to have some respiratory adjustments. Okay. Now what is everything sensitive to? Basically, everything is sensitive to high partial carbon dioxide level and high H plus concentration. That's like it's bad. It leads more production of carbon dioxide toxicity in the body. Hence, these are sensitive to this. And as soon as they get menstruation, OCT is rising, like even a bit, they're like, no, just go and stop. Go, right? Like go to war. This message is like medulla oblongata. That's my one, which is audible. Yeah. Then we have primary respiratory rhythm center. In the medulla oblongata, this primary respiratory respiratory rhythm center. All the base exists in that primary lung rhythm disorder. Primary receptory recipient disorder. Okay. Then we have certain disorders. Before that, the role of oxygen in the regulation of respiration rhythm is quite insignificant. Here we have disorders. Disorders are like again classified into three types, that is diseases, impact zone, and characteristics. First thing first, asthma. It's inflammation of bronchi bronchioles. Okay, wheezing sound. Inflammation of bronchi bronchioles. It's asthma, wheezing sound. Then we have emphysema. Emphysema is alveolar wall in chronic smokers. It actually like got full cut, so yeah, they're innovating it. Okay, emphysema, alveolar wall in chronic cigarette smokers exists. So yeah, the role of oxygen regulation of respiratory rhythm is insignificant. The role of production to work, role of production to workers engaged in industries that will involve in producing, grinding, and skinning. This is occupational. One of the questions, let's once go through body fluids and circulation because that was the first. Here we have the blood vascular system. Blood vascular system constituents of blood vessels, heart. It's synthesized in blood itself is synthesized in red bone marrow. Its components. Okay, these are components, that is plasma matrix 55%, water in plasma matrix, water is highest 90 to 92% water. Then we have protein, it's one of the highest after water. Then we have fibrinogens, clothing, then minerals like Na plus C plus Mg plus HCl3 Cl minus, all that are there. Then nutrients, glucose, amino acids, and recipients. These four having this whatever is given. In plasma matrix in the blood, it's present 155%. Like, the composition of water is 90 to 92%, protein is 6 to 8%. Then fibrinogens is clotting. Minerals is Na plus Ca plus 2, Mg plus 2, and HCO3 minus. Cl minus. These are the dead. Okay. The nutrient is glucose, amino acids, and lipids. Glucose, amino acids, and lipids are the nourishment for plasma. Functions performed by blood vasculatory system, let's see. That is transport of nutrients, O2 gas, etc., removal of harmful substances. And these functions are important. They do as per descriptive activities. Okay. Transport of nutrients, O2, glucose, etc., all nutrients. Then removal of harmful substances. Okay. These harmful substances are removed, or have they added? I have no idea. Medium of transport, water and body. So we have two medium of transport, water and other one is body and lip. Water, sponges and concentrates transportation mechanisms through water. Then even osmotic balance, that's of albumins. Albumins conduct plasma. Osmotic balance, it's a plasma, like that's where away. And then here, globulins defense. Globulins are defense. Formed elements is around 45%. Plasma alone is 55, whereas formed elements are around 45%. So parameter RBC, WBC, platelets, thrombocytes. The number, color, nucleus, lifespan, function. Cannot ask all that. We do. Then types of WBC, hidden scorilus ones with like known case. Granulocytes and agranulocytes. Granulocytes and agranulocytes are two types. I have this one whole page. First parameter, number, color, lifespan, function. So RBC is upon 5 to 5.5 million millimeter cube, 6,000 to 8,000 leukocytes. Yeah, millimeter cube, correct, 6,000 to 8,000. Then we have platelets around 1,50,000 to 3,50,000. That's of platelets or thrombocytes. Color of RBC is red due to iron containing hemoglobin 12 to 16 grams of it per 100 ml. Whereas WBC is colorless, then we have platelets, they are also colorless. Now, nucleus. Nucleus is absent, nucleus is present, nucleus is absent in platelets also. The nucleus is present only in the middle part, not even in my syllabus. So it's in leukocytes, it's there. Nucleus is present in leukocytes. Lifespan 120 days for RBC, generally short-lived leukocytes. Right? That is only 15 days, then short-lived, even platelets. Function. Transport of gases. RBC's function is of transporting gases. Then WB's is defense. Yeah, defense mechanism. It has that inbuilt also. Then coagulation of blood, if number drops, can lead to loss of blood flow. This is very important. Platelet number should never drop. If it drops, then a clotting factor also drops in the body, which leads to the increased blood flow. If there is any cut or something, and nothing will help it clot. That's a really bad condition. So platelets or thrombocytes number should never drop. Then now in WBC we have certain types, that is of granulocytes and agranulocytes. Granulocytes, it's like basophils, so eosinophils, neutrophils. Agranulocytes, it's monocytes and leukocytes. Granulocytes and agranulocytes. Okay, basophils, eosinophils, neutrophils. Okay, neutrophils is the most, has up to 60 to 65%. Then we have lymphocytes around 20 to 25%. Lymphocytes 20 to 25. Then monocytes is up to 6 to 8%. 68% monocytes. Neutrophils 60 to 80%. Then basophils at 10 to 0.5 to 1%. 0.5 to 1% is like a thing in basophils, whereas in eosinophils 2 to 3%. 3% of them. So what are they all involved in? Basophils is involved in inflammatory reactions, and eosinophils involved in reaction or infection, which before gave are associated with allergic reactions. So it's like associated with allergic reactions. It resists, but it triggers also. Yeah. It resists infections, but triggers allergic reactions. Okay, then we have phagocytic cells or phagocytic in action, that is neutrophils and monocytes. Both of them combined from granulocytes and agranulocytes form this phagocytic in addition. So lymphocytes in addition of summary response of my body. Reference. blood vascular system. Then do we have nodes? Yep. RBCs are biconcave and unucleated in most mammals. Very, very important. They will ask this because many things nucleated. No. RBC is enucleated in mammals. Graveyard of RBCs is spleen, meaning after 120 days lifespan, all the RBCs are dead in spleen. Then we have basophils secrete heparin, histamine, and serotonin. Yes, basophils secrete that because it comes out of mast cells. The mast cells they have heparin, serotonin, and histamine. Histamine is very, very good for digestion. It's recommended. Histamine, then serotonin. It is. Then the one skin, like it is says also. I want you to try. That was all. And platelets are all fragments of megakaryocytes. Fragments are called magnets. Fragments of megakaryocytes. Megakaryocytes in a sense, big karyocytes. Blood clotting or coagulation. That's where clotting factors come into play. And then we have blood vessels. After that, blood groups. Blood groups are based on the grouping mechanism also. These are some and lymph also tissue fluid. So yeah, okay. So blood clotting or coagulation. In response to injury or trauma, clotting prevents loss of blood from the body. Clotting. Okay. Events involved. Injured tissue, then platelets come suddenly. So injured platelets come. After that, they release certain chemicals. The platelets release certain chemicals. This is the cascade process where the chemicals are released by the proteins. That is known as cascade process. The formation of thrombokinase enzyme complex. Thrombokinase, what is thrombokinase? It's an example complex. Thrombokinase is an example complex. Plasma is a clotting factor, which is serum. Okay. Plasma minus clotting factor is serum. So anytime if we see a plasma which is without a clotting factor, it is serum. SERUM. Okay. Now yeah, formation of thrombokinase enzyme complex. Kharab. Enzyme complex. Then we have prothrombin and fibrinogens. Prothrombin clotting factor 2, fibrinogen clotting factor 1. Fibrinogen, prothrombin, thromboblast, then cash. Prothrombin's main element is thrombin, like in platelets. Fibrinogens, it's fight. Coagulation, reddish, brown clot fibrils. My elongated form of elements. That's when I could see the elongated form of elements when coagulation or reddish brown clot appear in practical usage. Then Ca plus 2 ions play an important role in clotting. Ca plus 2 plays a very important role in clotting. Clotting factors in blood are inactive. So clotting factors of blood are not inactive. I mean, on the common stage they are, but when something happens, they are the most active. The nervous impulses are given to them. Then we have blood vessels. They are symbol named tunica externa, tunica media, and tunica intima. Okay, tunica externa is the outermost one. Tunica media is middle one. Tunica intima is innermost. So composition of tunica externa: fibrous connective tissue and collagen fibers. Fibrous connective tissue and collagen fibers. Well, tunica media, that is stem. Smooth muscle and elastic fibers. Smooth muscles and elastic fibers is produced by the striatum, the outer part, but it's present middle, but in the outer part of the smooth. Then we have tunica intima, innermost spaces of endoderm. So here the innermost spaces are occupied just for that math class in the then here we do have small diagram representing it. Artery, thick, narrow, then vein, thin and wide. Okay, this is vein and say artery, then tunica, medium and lumen. Tunica media, not medium, it's media, then it's lumen. Okay, lymph we have. Lymph is a tissue fluid, very well said. Then it's colorless. Simple and simple, lymph is colorless. Okay, blood, that's larger proteins plus most formed elements. So we do have certain larger proteins and most formed elements. That is how blood's composition actually exists. Larger proteins of most formed elements. Yeah, they subtract. If you're not having, we add. Then reds and lymphocytes. Lymphocytes. These things are visible. Well, carrier of nutrients, hormone and tastes. Lymphatic vessel doesn't drain itself straight back to the major veins. We could have had something good, so our taste buds wouldn't crave for something more, is what they are telling that lymphatic veins drain inters- interstitial fluid back to major veins. Okay. Lymphatic vessels drain interstitial fluid back to major veins. Well, lacteals are lymph vessels in intestinal villi to absorb fat. Intestinal villi to absorb fat is lacteals. Lacteals help in the absorption of fat in lymph vessels. Okay. Then blood groups, heavy topic. Then circulatory system or circulatory pathways. That's a small topic. That is sinus, open and closed circulatory system. Sinuses is present in open, sinuses are absent in closed. Regulation of blood flow, imprecise in open, whereas it's precise in closed. For example, arthropods and mollusks are both open and closed is chordata and annulida. Okay, then we have this table. Well, yeah, auricle, ventricle, alveolar, and most reptiles. Most collide are most crocodile, eels, mammals. Okay, I can't put those. So, fishes pump deoxygenated blood to gills for oxygenation. So, first they actually bomb, like the pumping is deoxygenated blood, but that's what we get in that one. Here, by seeing the table, we can tell that fishes have one auricle and one ventricle, so two chamber. The circulation is single. Amphibians 12:1, the circulation is incomplete, whereas crocodile is mammals 2 double. The circulation is successfully complete. Well, that was all, and I hope you all enjoyed this session and felt it useful, and you also did simulation. See you soon. If you have any tests, then all the very best. See you soon. Till then, take care. Tata, bye bye.